Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss how to implement the circular queue using the linked list. In the last video, I have discussed how to implement the circular queue using the array. What is the limitation of using the arrays? The size of the circular queue depends on the size of the array. And always the arrays uses the static memory allocation, meaning is that the memory will be allocated during the compile time. You cannot increase the size of the array or decrease the size of the array during the runtime. So that's why the developers have designed the concept called dynamic memory allocation. Allocating the memory during the runtime, we will call it as dynamic memory allocation. Using the functions such as malloc, calloc and realloc, we can dynamically allocate the memory. So in this video, I want to discuss how to implement the circular queue using the linked list. So I request everyone to watch the complete video for better understanding. Let me give you an overview about the linked list. Then I will discuss what changes you have to do in the linked list to implement the circular queue. Now, a linked list is a collection of nodes and each nodes have two parts. One is the data and address to the next node. Look at each node. Each node has been allocated in some memory location. The first node is allocated in the 100 memory location and second node is allocated in the 200 and third node is in the 300. So they are not contiguous memory locations, whereas in array they are contiguous. So if you know the base address of the array, you can find any element in a particular indices. But coming to the linked list, they are not in contiguous locations, so you need to have the address of the next node to access the data which is there in the next node. And you will have a pointer called head which is pointing to the first node. And this is the last node. After this node, there is no other node, so which is not pointing to any other node, so you will have the null node. So this is an overview about the single linked list. Now we need to implement the circular queue. What is the circular queue? The circular queue is that you will have the two operations we will do on a queue. What is that? We will perform the enqueue. We will have the rear and we will have the front. Okay. Enqueue operation will be done from the rear and dequeue operation we will perform from the front. Am I right? Now usually the circular queue we will represent in a circle manner. Now let's take that the array size is 5. So you will have the index from 0 to 4. Is it clear? Now why I am saying it is a circular is you can go to the index 1 from index 0. From index 1 you can go to index 2, index 2 to index 3, index 3 to index 4. From index 4 you can go to the index 0. Is it clear? So initially the front and rear is equal to -1. If front and rear is equal to -1, then you will say that the circular queue is empty. Is it clear? If there is a single element, let's take that you have inserted an element 10 here, then front and rear will be pointing to the element 10 only. So front and rear will be equal to 0. Is it clear? Now you want to insert another element at the index 1. Then what you will write it is that rear is equal to rear plus 1 modulus size, where size is the size of an array. So you will increment the rear and modulus by the size. So rear is equal to 0, 0 plus 1 is 1, 1 modulus size, let's take that size of the array is 5, so 1 modulus 5 you will get 1. So rear will be pointing here. Okay, rear value will become 1 and front value is 0. So the next element here it will be there. So the first element in the circular queue will be pointing by the front and the last element in the circular queue will be pointing by the rear. Is it clear? So this is about the circular queue. Okay. Now I want to implement the circular queue using the linked list. Now what I should have? I need the two pointers. One is the front and the rear. So front will be always pointing to the first node. Front will be pointing to the first node and rear will be pointing to the last node. Okay. Because in a circular queue, the Enqueue operation and Dequeue operation should perform in order of 1. If we use only one pointer, any one, whether it is Enqueue or Dequeue, will take order of n. Is it clear? Are you able to understand? So to overcome that one, we are using the two pointers such as front and rear. Now as it is a circular queue, so this link should point to the first element in the node, means the first node address you need to have. So what is the first node? 100. So this address, if you are maintaining, then it is pointing. So now it is becoming a circular linked list. Is it clear? Because you want to maintain a circular queue, so the last node should point to the first node in the linked list. So now it is similar to circular linked list. So if you know the circular linked list concept, easily you can solve this problem. Okay. Now let me discuss each case. Like we have the Enqueue operation, we have the Dequeue operation, display and peak. All these things I will discuss one by one. Okay. So before doing all these things, you need to define a structure and declare some variables to it. I will do the structure definition globally. I will write strut node. Okay. Then I will write int data, because each node should have the data and address to the next node. So I will write strut node star next, which is a pointer pointing to the address of the next node. Then this is the structure definition. If you define a structure, the memory will not be allocated. You need to declare the variables to the structure also. So I need to declare two variables. One is the front and the rear of strut node type only. Initially, I need to initialize them to the null. If front and rear are equal to null, then you can say that circular queue is empty. Is it clear? Are you able to understand? Initially, front and rear is equal to null. They are not pointing to any node. If they are not pointing to any node, the circular queue is empty. So now first let me discuss about the Enqueue operation. What is Enqueue? Inserting an element into the circular queue, we'll call it as a Enqueue. So void Enqueue. Okay, is it clear? Now we will have certain cases. If the circular queue is empty, what should we do? If the circular queue is not empty, what we have to do, we will discuss. Now before Enqueue operation, we need to create a new node, okay, of strut node type. So let me write or declare the new node variable. Then I need to allocate the memory dynamically. So new node is equal to strut node star. You can allocate the memory dynamically using malloc or calloc. So I am using the malloc, okay, which returns the void pointer. So I am doing the typecasting. Then I need to mention the size of strut node. So whatever the node size is, that much size of memory will be allocated dynamically. So this node consists of two parts. One is the data and the address of the next node. Once it is dynamically allocated, we need to create a variable called x and ask the user to enter the data. So printf enter the data or enter the value. Once the user has entered the value, you need to scan it. So let me write it as scanf %d ampersand x. Once it has been read, you need to assign to the data. So new node of data is equal to x. New node of next is equal to null. Okay. So you have created a node, okay, consists of value. Suppose let's take that here the x value is 10. The value 10 will be here and it will be null. Suppose let's take that it is in address of some 100. Then you are declaring a pointer called new node, okay, This new node will consist of address 100 if the memory has been successfully allocated. If new node is equal to null, then due to some issue the malloc function cannot allocate the memory dynamically. Is it clear? So this function will either return the value null or it will return the address of the memory allocated. Is it clear? So this is pointing to this node. Is it clear? Now what we need to do, if the circular queue is empty, what we should do? How can you check whether the circular queue is empty or not? If you say front is equal to null, then circular queue is empty. Whatever the node you have created, it is the first node in the circular queue. So then what you need to do, you have front and rear is equal to null. Now if this is the first node, front and rear should be pointing to the same node. So to do that one, what we will do is that we will write, okay, we will write front is equal to rear is equal to new node, because new node has the address of this memory. So now front is consists of 100 and rear is also consists of 100. Both are pointing to this one. Now as it is a circular queue, the node itself need to point, because it should act as a circular. What is a circular queue or the circular linked list? The last node should point to the first node in the linked list. So this is the first node. So this node should point to this one only. So it should not have the value null. It should have the address which is 100. So how you will write it is that rear of next is nothing but this is the 100. 100's next is this one, should be equal to front. What is the value is there? Front 100. So that 100 will come here. So this node is pointing to itself. Okay. So this is about the, if the first node you are inserting in the circular queue, this is the operations you will do. Now let's take that it's else, meaning is that whatever the node you have created is not the first node. Let's take that user has again called the enqueue function. Then this time the user has allocated the value 20 here. Is it clear? Now what will happen? You have created a new node, okay, or let me write here, you have created another node now having the value 20 and having the value null. Now look at here, front is equal to null. Front is having the address 100, 100 is not equal to null. So this condition is false. If this condition is false, we will not execute these statements. We will execute the statements which are there in the else block. So now what are the statements I need to write? Look at here. Now what it should have? This is the new node. Suppose this address is 200. What I should do first? First I need to keep the 200 here. Am I right or wrong? Is it clear? This is the node, should have the 200. Then this rear should have the 200. And here in place of null, you should have the first node address 100. These are the three things we should do. One is that the previous node will have the null value, because that is the last. Null value means it will have the 100. Sorry for it is not null value. Initially it is having this value is 100 when we have created this node. Okay, are you able to understand? Here this node should point to this node. So what is the address of this node? 200. So here in place of 100 you need to make it as 200. And another thing is that now rear should point to this node. So rear should become 200. That is the step 2 you should do. And then in place of this null, what it should point to the first node. So here in place of null, you should get 100. These are the three things we should do. So first let me do the step 1. What is it? This is pointing by the rear. So you need to write rear of next is equal to 200. 200 is having the value, means which pointer is having the new node will have this one. Am I right or wrong? Because this is the new node you are creating. So 200 will be having in the new node. So you need to write rear of next is equal to new node. So Here in place of 100, you will get the value 200, not the value, it is the address. Okay, so now this node is pointing this node. Is it clear? Step 1 is done. Now here rear is having the 100. Now you should make rear is equal to 200. So what you will do is that rear is equal to rear of next. Rear of next is having the value 200. That 200 will come here. So now rear become 200. It is pointing to this node. So look at, front is having the value 100, so it is pointing to the first node. Rear is having the address 200, which is pointing to the last node. Now this one should be removed, null value should be removed and replaced with the address of the first node. So what you have to do is that rear of next, rear value is 200, 200 next is this one, should be equal to front. Is it clear? So this is our step 1 in the else block. This is the step 2. This is the step 3. Is it clear? So close the else block and close the enqueue function. So this is the operations, or these are the steps you should do whenever you are calling the enqueue function. I hope you have understood. Now let me discuss about the dequeue operation. What is meant by dequeue? Deleting an element from the circular queue is called as dequeue. Okay, so now we need to delete the elements. Whenever we are deleting the elements, we need to check certain conditions, whether the circular queue is empty or not, if the circular queue is having a single node or not, if the circular queue is having more than one node. All these 3 cases we need to look at. First let me define the function void dequeue. Void is specifies that this function does not return any value. Now first thing you need to check, if front is equal to null, then meaning is that circular queue is empty. If circular queue is empty, can you delete any elements? No. So you will write a statement called printf circular queue is empty. Okay, I hope it is clear for you. Else if front is equal to rear, when the front will be equal to rear, when you have the single node. Just now we have discussed, when we are inserting this node, front is having the value 100 and rear is also having the value 100. If you delete that node, then front and rear should be having the value null. Why? If you have a node and if you deleted that node, then it is empty. Am I right or wrong? So to do that one, what I have to do is that I need to follow certain things. First let me declare a strut node variable called temp. Okay, is it clear? So I have declared a temp variable, and after that I have written temp is equal to front. Okay, why I am doing it you will understand. So now let's assume that you have only one node. Okay, let me write here somewhere. Okay, you have only one node. Then one node means here also the next node will be, address will be 100 only. Now front is 100, rear will be 100, and even you have declared another variable called temp also, which is also 100. Am I right? Now what you need to do first you need to make front and rear is equal to null. Okay, so you will write front is equal to rear is equal to null. Now front and rear become the null pointers. Already in the C programming lectures I have discussed about various pointers. One of the pointer is null pointer. Okay, the null pointer does not point to any memory location. Okay, this is done. Now what you have to do, you have to release this memory which you have allocated. Using the function called free function, we can release the memory. Before releasing it, you have to make this node as null. Okay, so temp of next is equal to null. See, this you can, if you are not interested to write more steps, you can avoid it. but it is a good practice. So now it is becoming null. Okay, are you able to understand? Then you can write free of temp. So free is a function to release the memory. So how you can give it? You have to give the pointer which is pointing to this memory location. So free of temp will release the memory which has been allocated. Now still this temp is having the 100. So it is pointing to a an existing memory. So this memory 100 we have released. So now this memory is not there. So still it is pointing to 100, which will create as a dangling pointer problem. So that's why it is good practice to write temp is equal to null. Now this becomes a null pointer. So null pointer is not a problem, but dangling pointer is a problem. Okay. So now else if is done. Now I need to write if front is not equal to null, meaning is that the circular queue is not empty and only one element is not there. So this one is also false. Let's take this case. Now you have more than one node. If more than one node is there, what you have to do, let me discuss for you. Okay, this one is wrong. For the space issue, let me close this else if block here. Let me write the else. Meaning is that if these two conditions are false, what will happen? Meaning is that there are more than one node. If more than one node is there, where you have to delete it? Always you have to perform the dequeue operation from the front. Meaning is that you need to delete the first element from the circular queue. The first one is which is pointing by the point front. So what I have to do? Now if I delete this one, the front should point to this one. This is the step 1. Am I right? What is the step 1? Front is pointing to the first node. Now if I delete it, now front should point to the next node. Okay, next node is this one. So step 1 is that I have to write front is equal to, okay, front is equal to temp of next, because temp is also, it is pointing to front. So now temp is also having the 100. So front is equal to temp of next, which is 200. Now front is having the address 200, so which is pointing to this node. Is it clear? Here only 2 nodes are there. If 3 nodes are there, the front will be pointing to the second node. But as there are only 2 nodes, so front and rear now pointing to the last node or the second node. One step is done. Okay. Now what you have to do? You have to release this memory. Am I right? To do that one, what we will do is that we have to make this one as null. Okay. Oh, sorry. Why here 100 is null is there? Here it should be 100. Am I right or wrong? Now look at this one. This is the last node now, because if you delete this one, this is the last node. So what you have to write? Rear of next is equal to front. So rear of next is equal to front. This is the next step you have to write. Now rear of next, this rear of next, this one is front. So here you will get the address as 200. So this node is pointing to this node only, but still this node also pointing to this node. So this one you have to make it null. How you will make it null? You will write temp of next is equal to null. This is the step 3 you have to do. So temp is 100. 100 next is this one. You are making it as a null. If you are making it as a null, it is not pointing to anyone. Now you have to release this memory. So how you will do? Using the free function, you can do it. Okay, so this memory has been deallocated. If this memory has been deallocated, now you have to make it to the null pointer. So you will write temp is equal to null. Okay, close the else block, close the dequeue function. So this is the operations you have to do whenever you are calling the dequeue operation. So dequeue function, is it clear? So this is about the dequeue. Now let me discuss about the display. So display is what you are displaying the elements in the circular queue. So how you will display? You need to display from the front and go up to the rear. Okay. Let me discuss with a simple example. I will take a scenario where three elements are there. Okay. Or three nodes are there. Okay. Let me write here. Okay. This is 100. This is 200. This is 300. Okay. And this will have the address 200, this will have the address 300, this will have the address 100. So that's why it is pointing to the first node. Here value 10, 20, 30 is there. Are you able to understand? And then you have two pointers, one is front and rear. Front will be having the address 100, so that it is pointing to the first node, and rear will have the address 300. Okay, is it clear? Now look at here. Void display. First you need to check whether the queue is empty or not. If queue is empty, there are no elements in the circular queue, what you will display? You will display that circular queue is empty. So how you can check whether the circular queue is empty or not? Front is equal to null. Then you will display circular queue is empty. Okay, is it clear for you? Else, if there are some nodes are there, you need to display them. So to do that one, what we have to do is that we need to declare a variable called temp, and you should have the address, whatever the address is there at the front. Okay, after this one you should write. So now I have declared a variable called temp and assign the address as 100, which is having the address at the front. Now what you need to do? You need to display all the elements. So one by one, 10 you should display, 20, then 30. So what I will do is that I will write a while, okay, temp of next not equal to front, because how I can see that last node, this is the last node, how I can say temp of next, which is 100, once it is equal to front, then it is the last node. Am I right? Last node next will be pointing to the first node, which is having in the address called front. So whenever temp of next is equal to front, I need to stop this one. So what I need to do is that I need to print the elements. So print of %d \n, you can write the elements or whatever you want to write, you can write it. Print of %d \n, then you can write temp of data. Okay, then you have to write temp is equal to temp of next. You need to traverse, am I right, from first node to second node to third node, like that. Then we will write here also print of %d \n temp of data. Why this is also required, I will discuss for you. Instead of this one, instead of using while even, you can use the do while loop, but this is the best one. Okay, so let me close the else. Let me discuss with this example how it is working. Now temp is 100. Okay, temp of next is 200. 200 is not equal to front, 200 is not equal to 100. Temp of next is having address 200, which is not equal to front, which is 100. So this is true. If this condition is true, what you are doing? Print of %d temp of data, 10 will be printed. You are writing \n, the cursor will come to the next line. Then what you are doing? Temp is equal to temp of next. Temp is equal to temp of next, which is 200. So here you are getting the 200. Now look at here. Temp of next, 200 next is 300. 300 is not equal to front. They are saying, yes, 300 is not equal to 100. Again, this condition is true. If this condition is true, you need to execute the statements. Print of %d temp of data. Temp is having 200. 200 of data is 20. So that will be displayed as an output, and then it will go to the next line. Okay, now temp is equal to temp of next. 200s, next is 300. So here you are getting 300. Now look at here. What is the statement you have written? Temp of next not equal to front. 300 next is what? 100. Now 100 is equal to 100. So whatever this condition you said, it is false. If this condition is false, it has to come out from the while loop. After while loop, whatever the statement is there, that it should execute. So print of percentage D, temp of data. Temp is 300, 300 of data is 30. That 30 value will be displayed as an output. Then you have closed the else and you have to close the display function also. So this is the way you have to display the elements which are there in the circular queue. I hope you have understood. Now let me discuss another function called peek. Peek is useful for you to display the first element in the circular queue. The first element will be always pointing by the front. Okay, so with the help of that front pointer, you will display the first element in the circular queue. But we are just displaying the first element, we are not deleting it. Okay, so void peek. Okay, is it clear? So first you need to check whether circular queue is empty or not. How you can check whether circular queue is empty or not? If front is equal to null, then you will display circular queue is empty. Else, if it is false, then there are some elements are there in the circular queue. If there are some elements in the circular queue, you need to display the first element. So else you will write printf percentage D backslash n, you will write front of data. Close the else, close the function. Front is having the 100, 100 of data is 10, 10 will be displayed as an output. So I have discussed all the 4 functions such as enqueue, dequeue, display and peek, and even I have defined a structure called node, and even I declare few variables and I have initialized. Now what you need to do is that you need to write the main function. In earlier video when I was discussing how to implement the circular queue using array, I have written the main function also. Use that main function and use these functions, then you combine both of them, then execute the program, you will get the output. I hope you have understood about the circular queues. In the next video, I will discuss about the Dequeue, which is a double-ended queue. So I request you to watch the next video for better understanding. So if you still have any doubts regarding the circular queue, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.